Hello guys, I am Aditya Pawar and I am 12 years old. Today I am going to talk about black holes. So this is an introductory video of my whole playlist which I am gonna make in my YouTube channel. So if you don't watch my channel, please subscribe to my channel. My channel's name is given in the given below. So today we are going to do an informational video for the beginners who don't know what is a black hole, who don't know how do black holes look, who don't know how to see black hole, who don't know anything about black holes, only their name, but are interested, the layman, the lay people. So I am going to do that video for you. So this is a whole course, so you watch the whole course because everything is important in the whole course. I can't make the whole video because it is too large, so I have parted it as small parts. So I have made it as playlist. So please watch my whole playlist of black holes. So let's get started. So here we come. This is the first concept, that what are black holes. So the term black holes was coined by John Mitchell and Perry Dees Simon Laplace, who were the physicists of the 17th century, who used who used Newton's law of gravitation for the whole universe, which stated that every object acts upon every object, has force upon every object proportional to each other relative to their distance. So in this video, we are going to discuss black holes. So imagine you have a star. So the star is going through, the star has born from the nebula. So I am telling you the star cycle. So here we take a nebula, and then there are a lot of gas in that nebula. There are a lot of hydrogen, helium, lot of gases in the nebula. Then the nebula converts into a protostar, which we call a protostar. So that is a protostar, and then it converts into two phases. One is the giant and one is the small than the giant, but we don't I don't have the word for that. So our sun come in that stage, the second stage, which I don't have a word for. And there is the giant one. So the sun, if you turn the sun into black hole, it would compromise itself up to 6 kilometers only. That is so small, smaller than the earth's radius and diameter. So then the sun will go to some giant phase of it, then giant phase, and then that is the whole life cycle, and then collapse without forming nothing, not the nebula, not the neutron star, and not the black hole. But the second type is very special because there is a giant which turns into a supergiant, which turns into a hypergiant, and then it goes to the next phase, which is supernova 2. Remember the word supernova 2. Astrophysicists call it supernova 2. That is a form. So the energy created from that form goes back to the nebula form, and then the cycle whole continues. But after the formation of the formation of the supernova 2, then they form into two versions. The first version is neutron star, and the second version is of a black hole. So this was the first question I have whole evolved. Now this was only the star formation. Now I am going to talk about how a black hole forms this. So we have a limit. If there is a star but it is a dwarf star, so we have a limit for it. It is called Chandrasekhar's limit. Chandrasekhar, Subramanian Chandrasekhar, who was a physicist of India, and calculated all the sums and equations, including maths, to find how stars born and how stars are died. So that limit, certain limit we have, It is called the Chandrasekhar's limit for a white dwarf star. But when you take the star like sun, so the sun is 5,000 billion years old. We know that. So the sun was 5,000 billion years ago was formed. So from that age, it has evolved many much. It has given lots of energy. It has radiated very much, but the gravity of the sun is not much increased or not much decreased, because the sun is at the normal stage. It has only evolved by the radiated heat, by the light it has produced. It produces lots of light and heat and wastes lots of light and heat. So from that stage we come to the sun, and then now the sun is doing its what we call in the astrophysics language is called nucleosynthesis, just like a photosynthesis in plants, which happen that they take in carbon dioxide and give out oxygen from the stomata cells. But this is in the astrophysics term, this is nucleosynthesis. So this is star nucleosynthesis. Nucleosynthesis spelling NUCLEO, nucleo, and synthesis SYNthesis. So nucleo and synthesis. Synthesis meaning something is performed, and nucleo meaning something is crusted or destroyed, anything like that. So this was the term nucleosynthesis. So the star goes through its life cycle, the whole year, until its last stage when it is very old and can't hold a penny. Then the interesting thing happens to be a black hole. So what the thing happens is that the star has fueled up so much energy. When it was born, it was fulfilled of energy, but as it grows ager, it decreases energy. And when he is very old, the star is very old, then the energy decreases and comes at a point that there is nothing, no energy. So the star itself gets contracting because of heavier elements such as helium, iron, deuterium, lithium, such heavy elements. Because when the star was young age, when the youth of star was happening, it was fulfilled of energy and producing more energy, and the it was only using hydrogen and helium, but now it is now it is producing lithium, deuterium, so which are heavy elements to hold the star. So this just like we put a trampoline and we put an object on that. Why does the trampoline gets wrapped? Why does that area where the object is kept get wrapped? Because of the mass of the object. If it overloads, then it goes more down, it gets more wrapped, like a black hole singularity. I will talk in the next session. But in this, I'm explaining you how to generalize this concept. So I've seen in Brian Greene, who is a famous physicist, American physicist, Brian Randolph Greene. He says that we take a star, we take a earth, then the earth is spherical, we know that. Then we put a cannon 90 degrees to the earth, as we imagine 90 degrees to the earth, and then we shoot a bomb or a ball, we shoot a ball, and then because of the low pressure, in this is the first case where there is low pressure, so the ball goes up, little up, and then comes down. We all know that because of the gravity, immense gravity. As you go higher, the immense gravity falls upon you very much, but after you escaped in the space, the gravity much more or less contrast to act upon you. So now we take the second case. First case is over. Second case, we again have the cannon, but we have intermediate filled it with the gunpowder, which is the main source to shoot the ball up in the sky. So we have intermediate level of gunpowder, and then we take fire and we shoot gunpowder. So it goes much higher than in the first case, because we have low energy, now we have intermediate energy. So these are the differences. As the star was young, it was in this case. As the star turns to youth, it is in this case. So the star is producing more energy, but as the star goes older, goes older, we come in third case. So in the third case, we can't attempt that case, because it is not like an experiment like we do in first or second. We can do first or second, but the third one is hypothetical. So we take that same cannon and we put the ball, and imagine that there is so much energy in the cannon that it pushes the ball so high that the ball never comes. So this you would like that is friction is not more any there, gravity is not more, gravity is not playing its role, or gravity is fake. But that is a thought experiment, experimental thought experiment, which was coined by John Mitchell and Perry Simon Laplace. That's how they make that the black holes were existing. But Einstein didn't know that black holes existing. Therefore the theory which he made, E equals mc square, energy equals mass multiplied by speed of light squared, he made that theory general theory of relativity. That theory now we use after the 100 years of Einstein's death. We also use it to understand black holes and to understand planetary orbits, anything in the wrapped space. Einstein said himself that the space time, the fabric of space time is not smooth, the fabric of space time is not plain, but instead it is very much curved. Like we have trampoline, and suppose you are standing on the trampoline, and then you see that because the weight you have, the trampoline gets little down. Because of your weight, the trampoline gets inwards. Because of your weight, the point of weight, center of mass of your whole body is inserting on the trampoline. But if you are lighter, then the trampoline much wouldn't get much effect. And if none is there or air is there, so we see that if no people is standing or no object is on the trampoline, so it is plain, because there is no object to act upon it, to put force upon it, to have matter in the Newton's laws of gravity. We understand it that if a object has mass, then only it will have gravity, then only it will have its own force, just like planets do. If we have earth, the north and south poles, we take a magnitude like bar, we have these hypothetical bars. But just like that, earth also has a gravitational wave, which was coined by some scientist. That was like it was from the equators and to the back, and the solar rays are coming from this side, the solar rays are coming from this side, and the earth is protecting because of the gravitational wave. The gravitational waves are this like, and the earth's waves, sorry, the sun's waves, which are ultraviolet waves, which are harmful for humans, goes like this over there, over the earth. So why does this? Because of the protection of gravity, gravitational lines around the earth. And we also know that the ozone layer, which is in the stratosphere layer of our atmosphere, there are many layers: troposphere, stratosphere, mesosphere, thermosphere, exosphere. So in the stratosphere layer, the suns, which there is a ozone layer, and the sun's rays come in, but the ozone layer didn't provide much wavelengths to be entered in the earth. It provides sufficient amount of wavelength to enter the earth. So the other radiations you see there are also radiations, but the earth is not affected by it because ozone protects it. But if the ozone does not protect it, if there is no ozone, then we would be burnt alive. Like this, we would be burnt alive, and in the night we will freeze down. We will freeze down because of cold. the air would come in and come go, and we would also have that, because the ozone is ozone is very much ozone the ozone layer protects very much, and it is very thin layer, just like you apply sunscreen to it. So just you apply sunscreen to it, it becomes like that protects sun tan. What does tan causes? Tan causes your skin to look like black. But if you apply sunscreen, there is no tan. Just like that, imagine the body of our surface as the earth, and the layer of blanket as sunscreen. Then the sunscreen is all over the earth, in all the direction, in the all four directions, protecting our earth to be alive. So now the question comes that, from this, what do I have understanded you, what do I have teach you? So I have not teach you very much, but the example I have given you is very important. Example you also have to look, and the you will find, if you study the whole black hole, yeah, it on any website by any physicist, by any scientist, or by some research only, some little research only. If you are not from, you can take it from scratch. Then after some 1 month or 2 months, you will become professional in it. And then if you watch my video, this video I'm doing right live here with your live interaction with me, if you watch this video, then you will know what I am talking about. So I am talking because I have researched this whole day, whole night. I have researched this and make up the collection of data. But to present it, you also have to do some contributions by liking and subscribing my video. So let's go to the next part of the video.